No, I'm committed to what I'm at. Okay, combinations of permutations. Combinations order doesn't matter. Permutations order matters. Now, a combination example would be, remember when I told you in this class I was picking, like, we'll say 3 people to go on a trip. I think it was 6, but I'm downplaying it. I'm 4 now. So I'm picking 3 people to go on a trip. Okay? Paying attention? All right. So the first person gets to go to Walmart. Just go to Walmart. That's your trip. The second person gets to go to 7-Eleven and gets $10. Remember? Poor. And no, they should go to Walmart. It's a trip. A real treat. And then the third trip is to downtown Okotoks, blindfolded.
Into the street.
That's a terrible trip. That's worse than Walmart. Without any money. So, okay. No, you get to stay on the sidewalk, and you get to go into a store with some money that you can't see, and hope to buy something that you have enough money for. That's the trip. You're welcome. You, of course. Who invited you?
My cousin works there.
Yeah, okay. So, those are the 3 trips. Those are the 3 trips. Does order matter or not matter?
Yeah, nice.
What?
It does.
It does. Why does it?
Because depending on which position you're chosen in, depends on where you're going.
Right. Because just going to Walmart, which I hate, and then without any money would be possibly the worst thing ever. I would rather just stay home, personally. Anyway, so the way we would do that is say we have 20, I don't know what I'm writing here. We have 24 kids in class, correct? We would go 24, and then we'd go P3. Because it all depends on these ones that you're picking. If the order of picking them makes you do different things, it's a P, okay? Now, how could I change it so that I could actually use 24C3? How could I change it? They're just random. So they would all have to go where? To the same place. Like if they all got to just go to Walmart without money, then it would be a C. Because if you were picked first, second, or third, you get to go to Walmart with no money, right? It doesn't make you any more special if you pick first, second, or third. If you're picked fourth, you don't get to go. There you go. That's it. So the difference between P and C is P order matters, C order doesn't matter. So I always have to look at the number I'm choosing. This 3 that I'm choosing here, the order mattered because I gave 3 different things for you to do, correct? In order for it to be C, the order won't matter because I would get you to do the same thing. You get to go on a trip or you don't, right? Like you all get to go to Hawaii or you don't. But if you get to go to Hawaii and then United States and then Nova Scotia, those are 3 different places, it would be a P. Okay? Order matters if you give those people different things to do. So it could be vice president, president, secretary, or they all just get to be on a committee. If you just get to be on a committee, C. If you give them all jobs, different jobs, P. Okay, order mattering, not mattering. So let's look at this one. Discuss how throwing 3 toys in a bag is different than lining the 3 toys up. Taking 3 toys, throwing them in a bag is different than going and lining up the 3 toys. Yeah?
Well, when you throw the toys in the bag, they'll just be together, or like they'll be in order if they're all lined up.
Right. So in the bag, they would be a what? A combination. Exactly. So 3 toys in the bag would be 3C3, which is actually 1. I take the 3 toys and I go like this. One way. I don't care what order they flew into that bag. They're in the bag, throw them in the backpack, and I go home with my 3 toys. It doesn't make a difference, correct? But if I'm lining up 3 toys, that's the same as 3P3, which is actually 6. And the reason why it is 6 is this. If I use the letter P, yeah?
Is it 3 times 2 times 1?
Yes. If I use the letters P, I can use the blanks. Now this is what it is. This number here represents the number of blanks. I have 3 blanks. And this represents the number of objects. So what I start with the blanks with. And I'll show you when it's not 3 and 3 because that just seems ridiculous. So I have 3 blanks. And this first blank can have how many toys? 3. Then I put a toy there, correct? Then how many for this one? Then I leave a toy there then. The people who say 3, then 3, then 3, you're saying I have 3 toys here. I pick them up, I put them in my hands, And then I go to the next blank and I put all three toys down, 3 toys back down, can't speak. Didn't wreck the marker, that's a win. And then 3 toys again. Am I ever leaving a toy? Am I ever arranging toys if I'm laying down one and then picking it back up and then laying down one and then picking it? So if I go 3, 3, 3, I'm not actually ever arranging a toy. I'm never leaving one there to arrange it, correct? Okay, now just another example because 3p3 kind of sounds stupid, and they're both 3s. What if I did 10p3 instead? This would represent how many blanks? 3. And this would represent my total number of objects. So how many would I have for here? 10, then I'd leave one then, exactly. So you see what the P represents with blanks? Same thing. See, order doesn't matter, so I can never do blanks. The moment you put blanks like this, you're actually ordering them. You're putting something in this blank, then you're putting something in this blank, then you're giving it order. You're arranging it. So the word arrangement also gives away, or order gives away that it's a permutation. All right. Combination formulas are NCR. It's this formula here. Now off to the side, you're going to do something so you believe me. Okay? Now, NCR is this formula. I'm going to tell you right now that 10C6 actually equals 10C4. Now you're going to type them in. So go 10, math, over to probability, number 3, I think. Math, over to probability, and I think it's number 3. You see?
Yeah.
And then 6. What do you get for an answer?
210.
Okay, now go 10p4.
10C4 or 10P?
That's a C. I did say P, but I didn't mean to say P. 10C4. It's the same thing. This only works for C's, just so you know. And I'm going to show you why. Let me show you. Okay. Formula. Here's our formula here. Do you see it? So I'm going to go 10 for N and 6 for R on this side. Okay? So I'm going to go 10 factorial, because I'm going to fill it in for N. 10 factorial over 10 minus 6 factorial, because it's N minus R factorial. 6 factorial. Which is actually the same as 10 factorial over 4 factorial, 6 factorial. Don't know why I'm putting in separate brackets. I think it's for fun. So that's just the left side. Do you see that? If I type that all in, I get 210. We've already found that out. But I want to do it without numbers. So then I'm going to do the right-hand side. Now instead of my N is going to be 10, and my R is going to be 4. So I'm going to go 10 factorial, because it's N factorial, over N minus R. So it's 10 minus 4 factorial, 4 factorial, which is actually 10 factorial over 6 factorial, 4 factorial.
That's crazy.
To the same answer, correct? Because 4 factorial times 6 factorial is the same as 6 factorial times 4 factorial because of the commutative property of multiplication. It only works with C's and not with P's because P's doesn't have that extra R factorial under it. If you look, P is N factorial over N minus R. C is N factorial over N minus R, R factorial. So it has that extra R. Now, it works when the difference between them is the same. So, what does that mean? 10C6 has what's the difference between 10 and 6?
4.
So 10C4 is the same as it. So if I give you 20C15, it would equal 20C5. Because you're going to go 20 minus 5, which is 15, and you're going to go 20 minus 15, which is 5, right? You're going to get the opposite of it. So it's the common difference between them. So sometimes instead of if your answer, say I have 20 people, I'm choosing 15 to go on a trip. That's it. So I would give different trips. It'd be 20C15, correct? But they could give the answer 20C5 because it's the same answer. 20C15 is the same as 20C5. The other thing with C's is they can come in these stupid brackets. I mean, awesome brackets. So if you have 10C2, I can write that as 10-2 in big brackets. That means 10C2. And it actually shows it on your formula sheet. This is yours. NCR equals NR in those big brackets. Like it tells you what it is. So if you're stuck and you're like, I don't remember, you can go here. NCR. Well, what does 10C2 equal? 10C2 equals 10C 8, because the difference between 10 and 2 is 8. This does not work with P's though, right? It's the same thing. And so we get 10 and 8. And the reason why it happens is, if I go 10 minus 8, I'm going to get 2 factorial times 8 factorial. If I go 10 minus 2, I get 8 factorial times 2 factorial. Like, it's just going to give you the opposites. But when you multiply them, you get the same answer. It only works with C's. So the generic formula that they gave here was this one. NCR equals NC, the difference of these two. What's the difference of N and R? N minus R. So that's why it's written like that. NCR equals NC N minus R, the difference of the two. So example 1, 3 students from a class of 10 are to be chosen to go on a school trip. People are really good at C's, if they know it's a C. Like these questions get done terribly because people will sit there and go, I don't know if it's C or P. Remember that the people you're choosing, if they have jobs or something different, then it is a P. If they're chosen first, second, or third and it makes no difference, it's a C. So an example could be awards. If I give you, I'm choosing 4 people to get awards, and they all get the same award. They all get a backpack. Does the order matter if you're first, second, third, or fourth? I don't know why I picked backpack. That's where I went to. I probably still looked at a backpack. It's a super cool award. 1, 2, 3, 4. If you're picked first, second, third, or fourth, you get the same backpack. It doesn't even have your name on it. It is not special. It is just a backpack. It might even be a backpack that falls apart for all I care. First, second, third, fourth, same award. What would that be? C. What happens if I give you a first, second, third, or fourth award that are different? First, second, third, fourth.
P.
It's P. The moment you say they win first, second, third, or fourth, it's P. And if you tell me order doesn't matter, talk to an Olympian who gets fourth. It matters. They're bummed. Would you be bummed though? Really? I can see you'd be bummed that you got fourth, but you're like fourth in the entire world. I feel like that's pretty awesome. I think you'd be bummed because it's the Olympics and you got fourth, but like really.
You've been training your entire life.
But I get that, but if you think about it, really, you're fourth in the entire world.
That's not first.
So like a gymnast getting fourth, I'm like, wow, you're amazing. I can't sit cross-legged, And I know they're sad and they're crying, but I'm like, dude, can't sit cross-legged. So, exactly. I see it sad. But that's what I mean. First, second, third, if you give them awards, it's a permutation. If they win the same award as the first, second, or third, though, it'd be a combination. Okay. Yeah. So here, example 3. 3 students from a class of 10 are chosen to go on a school trip. Shocking that I'm doing this question. And how many ways can this be selected? 3 students out of 10 go on a school trip. Is it a perm or a com? Why? They're just going to get to go on the trip or they don't. So if you can go on the trip or you don't, or you get to be on the committee or you can't, that's all a combination because you're not giving those 3 people anything special if they're first, second, or third, right? So how many am I choosing from? 10, and I choose 3. 10C3 doesn't mean choose, I just say choose, but it means that I have 10 objects, I'm picking 3 at a time, and these 3, if you're picked first, second, or third, makes no difference. What is that equal to? 10C7. And why is it equal to 10C7? Shh. Because they just end up being the same thing as the formula with that little r factorial, correct? Also, 10.3, 10.7. Did you know that they can actually ask you to explain what your answer is? Because remember that the written response can ask things. So just getting 10C3, remember your written response are out of 3 or 2 marks. Your written response on your diploma are out of 3 or 2 marks. 3 or 2, that's what I did. 3 or 2 marks, every single one of them, correct? If this question is asked, that is 1 mark. They're going to have to ask more to get 2 or 3 marks, correct? So sometimes they might say, what's the solution? And you'll say 10 out of 3, and they'll say, what are the 2 different solutions that you can represent, or why? They might ask why 10C3 is the same as 10C7. And how would you prove it? You wouldn't just type them in your calculator and say 210, 210. That's not going to get you marks.
Write it out and get the same denominator.
You would have to use the what? The formulas. You'd have to use the NCR formula and do exactly what I did and show that they equal each other, working their ways down. And explain that two numbers that are multiplied, whether they're in this order or this order, is the same thing, right? You'd have to explain through it. Okay, so type in 10C3. What do you get? Or 10C7, or 10.3, or 10.7. 120. So there are 120 different ways that I can pick 3 people to go on a school trip out of 10. Nothing special. Go 10B3, which is totally incorrect. Is it going to be bigger or smaller? Bigger, because you're giving them order, right? It's 720. Do you think they'll have that answer on the diploma in the multiple choice? Yep. Gets picked equally as much as the C. Hopefully not from this class. So they'll always have the P answer and they'll always have the C answer. So if you're like, well, I'll just bank on the answer being there, both of them will be there. So if you don't know what you're doing, it's going to be a fitty-fitty. It's going to be real awful. Okay. Lotto 649. If you don't know how the Lotto 649 works, you pick 6 numbers out of 49, hence why it's 649. The cool thing about the Lotto 649 is that order doesn't matter. You just have to have the 6 numbers. If order mattered, no one would ever win the lottery, actually. It would take it's like hard enough to win now. So when you get the 6 numbers, if they pop out like 1, then 49, then 7, then 8, then 2, and whatever, if they pop out like that, it doesn't matter as long as you have the 6 numbers. Okay? The order in which they pop out doesn't matter. So here it says, Jasper selected the 6 different numbers out of the birth dates of his family, 3, 7, 9, 11, 20, 29. How many different selections of numbers could he have made? So that's the one selection he made. How many could he have made? How many numbers does he have to choose from? 49. Does the order in which he chooses them matter? No, because I just told you it doesn't. And how many is he choosing?
6.
So go 49C6. Can I go blanks? Can I do blanks? If it's a C, if I do blanks, what does blanks mean? I'm putting it in order, and that's a P, not a C. So I get people going 49C6, and then they go 49 times. I'm like, you just did both. You just picked both off. It's not helpful. What's 49C6? A large number.
1, 3, 9, 8, 3, 8, 1, 6.
1, 6? So just with no order mattering, you have a 1 in 13,983,816 chance without it mattering. If it did matter, go 49P6.
1.006 times 10 to the 10 times 10.
So it would be 100,683,4,752. Why did they put e to the 10? They could just put the dang number down. Anyways, it would be 1, 2, 3.
No, that's just
10 to the 10.
It's 68,347,520, something like that. It's in the billions. It's giant.
There's not even that many people.
No. It would be bad.
And there's not even that many that can buy.
It's just bad. Plus the thing is people will say, oh, there's 13,983,816 people. They're like, we can just have that many people buy it. And then, no, because some people have the same ticket.
Yeah, my grandpa's mine.
And his grandma's buying half of that. And like one choice often is like $20. So like even if you won, it's a lot of money. Right? Even if the tickets were $1, that's $13 million. That's cray-cray. Yeah.
Is that how many tickets there are?
That's how many different numbers of 6 number tickets you could have.
But
What if you bought all of them?
Yes.
Because people like choose
Because people can have, because some people split the lotto because they have the same numbers.
Imagine if you
Like just because you pick 6 numbers doesn't mean they can't be picked by someone else. Yeah. So sometimes the lotto doesn't get one for forever, and the next time it gets 4 people have the same number.
You win like a $6
Yeah.
million jackpot between 8.
Okay. Let's look at this one. So this one here we have the athletic council decides to form, and I talk like I really know what I'm doing. I think I've got the lotto twice. I sound like I'm a super Lotto person here, but like I never win and I never buy them, so I don't know why that doesn't work.
That's probably why you never won it.
Oh, that's why. Yeah.
Like the my grade. The thing my grade auntie, her and 11 of her coworkers all bought a bunch of tickets.
Oh, I heard about that
They won
one.
like $40 million.
Because you weren't even born yet, but I did. I heard about that.
And so they split it off, and then like, so my great auntie, great or great great auntie, a bunch of her friends won it.
They split it. They won the Lotto and they split it.
One time my grandma won $20.
What?
Yeah.
Go grandma.
Did you hear that?
Okay.
No, I didn't either.
My grandma won a dime once.
Okay, the athletic council decides to form a subcommittee of 7 council members, okay? We have to read that thoroughly. We need a subcommittee of 7 council members. The moment I see that, I know I'm choosing 7, correct? Because I need a subcommittee of 7 council members. What I need to do next is figure out if those 7 people are any more special if they're picked first, second, third, fourth, fifth, sixth, or 7th. If they are, it's a P. If they're not, it's a C, right? That's where I immediately have to go here. So I know I'm going to have to choose 7. I'm going to have to choose 7 of something. 7. I'm going to put that there. Then I have to decide if it's a P or a C, so I have to keep reading. To look at how funds raised should be spent on sport activities in the school. Did they give them jobs or anything? Are there any jobs for those 7 people? One a president, one a secretary, one a garbage picker? Anything? No, garbage pickers make it all the time because I run out of ideas. And things like that. Sweeper? I don't know. So they don't have any special jobs, so we know it's a C no matter what. We know it's a combination because those 7 people do not have specific jobs. You're not more special if you're first, second, third, fourth, fifth, sixth, or 7th. So let's read on. There are a total of 15 athletic members, council members. So how many do I have to choose from? 15 total. We agree? Then they're going to break it up. 15 total members. 9 are male, 6 are female. The subcommittee must consist of exactly 3 females. So what I get is people will see exactly 3 females and then they just choose 3. But up top, what did it say we have to choose for our subcommittee? 7. So you have to watch yourselves. It says I have to choose 7. So if it says I have to choose exactly 3 females, what must I also choose? And 4 males. So that's what that's saying. Now I know I need to choose 3 females and, which is what symbol? Multiplication. I have to choose 4 males. We agree? Because those 3 and those 4 have nothing, no special jobs or anything. We agree? Now, how can I guarantee getting females? 6. I choose from the females. And then the males, I choose from the males.
9.
And what do I get? Type it in. Quiet, please. 6C3 times 9C4, because that equals 7.
126.
26? So sometimes your subcommittees have to get split up. Now, what if it just said I need a 7-person subcommittee? It's not right. You guys are all giving me these weird sideways glances. What's happening?
I think, well, I don't know.
Did you add them?
Like,
How?
you bracket them?
No.
No, just put times.
That's
Yep.
It's like 2,500.
Oh wait, times?
Did you
I
add them?
just wanted 9. I'm sorry.
Oh, yeah, it's okay.
It's 2,500.
Ah, there we go. We found it. It's there. Okay. Shh. Example 4. This is a card game. Now on tests, they often won't give, like on a diploma, if they give a card game, they often make a generic deck of cards. They'll be like, there's 4 suits, blue, red, pink, and orange, and they're numbered 1 to 6 or something like that, so that you don't have a deficit if you played cards or not. I always thought everyone played cards. That is not the case. There are some people who have no clue what's in a deck. So, ouch. So, I kind of agree, but, you know, I don't want to say it. Just kidding. Not kidding. Kidding. You'll have to figure out what I am. All right. So, if I give you a card question on a test, though, I'll list this because I don't want it to be a deficit if you haven't played cards or not. Because that's not the point. The point is not like, do you know there's kings, queens, jacks, and aces, and the kings, queens, and jacks have faces, aka face cards. Like, I don't want that to be the reason why you can't get the question right. I want the reason why you can't get the question right is because you don't know how to do it. I don't really want that either. I don't know why you get the question right, but you know what I'm saying. Anyways,
Rather give us a chance.
I'd rather give you a chance.
Rather it be our fault than your fault.
Right, true. Thank you. That's exactly what I was thinking. Okay. We have a standard deck of 52 cards. Every card deck has 52 in it. There are 4 suits: spades, clubs, diamonds, and hearts. So how many cards are in a suit? 13. How'd you do that? You went 52 divided by?
It says each suit.
Or it says.
Or it's just like, has the.
If I don't give that, how could you figure it out?
Divide by
52 divided by 4. I knew what you meant. Each suit has 13 cards. 2 suits are black, the spades and the clubs. 2 suits are red, the diamonds and the hearts. Face cards are considered to be jacks, queens, and kings. I really want to write face cards have faces. Like an ace doesn't have, people will be like, does an ace have a face? I'm like, although they rhyme,
yes.
an ace does not have a face. The jack, king, and queen do because they're like royalty and they have faces. It can be high or low, but it don't have face ever. Okay, so here it says for cards, there are often combinations because the moment you get cards in your hand, if you actually play cards, the moment you get cards in your hand, what often do you do right away? Organize them. You move them around. So does the order matter?
Yes.
No, you got them given to you and then you just move them anywhere. So the order matters to you in which way, but order mattering would mean like if we were playing war. When you play war, does order matter?
Yes.
Yeah, you get a deck of cards, they're face down, and you have to flip, right? You have no choice what's there. But if you're playing poker or something where like the cards you flip here, you can move them around, right? You can put the queens together, the clubs together, you can make clauses, etc. Then the order didn't matter because you moved them. We agree? You don't have to play them in the order that was handed to you. So most cards are combinations. So here it says, how many different 5-card poker hands are possible? So it's a combination because it's poker. And how many cards am I choosing? 5. Out of how many? 52, because it didn't say they have to be jokers, kings, jokers, what the heck? Jacks, queens, aces, 2s, 4s, clubs, spades, didn't say anything like that. So put 52C5 in, you get a lot.
Don't how the card game works on a question. And then you don't know if it matters or not.
You will.
Okay. There's not that many.
It's cards, just cards, just combinations.
It's like cards on math class.
It's like
you
no
get better
fish.
No. What you got? Okay. If you're someone, and I know this has nothing to do with grade 12, but if you're someone who struggles with saying numbers, which some people do, so if I take this number, I'm not saying it's you. That wasn't what I meant. I'm just saying this because even my daughter struggled, and then I showed her this, and she quit struggling. All you have to do is you literally make sure you have spaces of 3s. So I made her do this, right? You work from your way back in spaces of 3s, and then you just say the number and what position it's in. So what number is this? This is a 2, and it's in the millions. This is what number? 598, and it's in the, and then this is 960. You just said the number. 2,598,960. As long as you can read 3-digit numbers, you can read any number.
Could you not just say 598,960?
Sorry?
I was just trying to do it in my head.
So if you went like this, say you had this. So say we do this, we block in blocks of 3s, right? So what number is this?
6,789,433,800.
You just have to read a 3-digit number with the space it's in. 6,789,453,800. You just read the 3-digit and the space it's in. That's it. People shouldn't struggle. I missed it. I'm glad I did. Okay. In how many hands will there be all diamonds? How do I do this? How do I guarantee getting diamonds?
13.
13C5. Shh. It's 13C5 because I have 13 diamonds and I choose 5. The only way I can guarantee getting diamonds is from diamonds. I'm not going to do the answer because that's just typing in your calculator and hopefully you can do that. 4 black cards and 1 red card. How many cards is that? That's 5. How do I guarantee getting black cards? Nope. How many black cards are there? 26. Half the deck. 26C. 4 and means I multiply. And then how many red cards are there? 26C1. Before I leave this question, I always have to check, did I actually choose 5 cards? Just like that 7-person subcommittee, I have to make sure I chose 7. Here I have to make sure I choose 5. Did I choose 5? Yes. 4 and 1 in the other, that's 5. We know we're good. 3 kings and 2 queens. How many kings are there? 4, 1 in every suit. And I choose 3 and means I multiply queens. How many queens are there? And I choose 2. Now I have to ask myself before I move on, did I choose 5 cards? Yes. Half your deck. Half of 52 is red, half of 52 is black. 26 cards.
Okay.
That makes sense.
Well, half the deck is black and half the deck is
Yeah, I
red.
get that. I just don't understand where it's asking between 2 sets. Unless I'm
It's
blind.
not, but it's just the possibility of
Half the deck is,
Just keep going, it's fine.
half the deck is black.
And add.
No, I got that.
No, that's not her problem. She's struggling with
Yeah.
something else. I just don't know what it is.
Like, how did you, the 26 is how
Did
you
you get?
No,
Where's
the
the
26 is one deck.
One deck split. There's 52 cards in total,
Yeah.
and then half of the deck is red, and I'm only allowed to pick red, and then half of the deck, you know what I mean? So it's 1.
Okay.
Yeah.
Now I get it.
So I always have 52 to choose from, but sometimes I can't choose all of them because I have to have this many red and this many black, or this many queens and this many kings. So it limits
So then
me.
you,
Yeah. So here I have 3 kings. What am I going to do? This is the tricky one. 4 choose, 3 because I have 4 kings. And then people will give me this answer, and I promise you that answer will be one of the multiple choice, and it will be wrong, and you won't even know it. What did I tell you? Right off the hop, how many of these cards did we have to pick to make a hand? 5. And how many do I have sitting here? 3. So I'm sitting here being like, dealer, give me 2 more cards. You suck. That's what I'm thinking. Right? You're not thinking that. You're circling the answer and you're moving on, but you're wrong. Because I need to have 5. Now this is the thing. I need 3 kings. This means exactly 3 kings. So I have to get how many more cards? 2, and they can't be what? So I need and 2, technically not kings. So how many cards are there in total? 52, and I have to take out all the kings now. So I have 48 left, right? So I have 52 cards, and I have to not have kings. Now, me, Crystal, in high school was stupid, and maybe you're in the same boat, so I want to make sure you're not as stupid as Crystal was, because she didn't know this till like later. It was way too late. But I was like, I used up 3 kings, so I have 49 cards left. That's great, I have 49 cards left, but I need these 2 to not be kings. So I have to take the deck of 52, and I take all the kings, toss them behind my back, and say, how many do I have left? 48. Not 49, 48. So I go, and I have 48 that are not kings, and I'm going to choose 2 of them. Do you see that? I would have put 49 every day, all day in high school. I got it wrong. Every day, all day. Yeah.
why are they 2 not?
Because I need to have 5 cards in my hand. And if I only pick 3 kings, I'm sitting here going, can you give me 2 more cards, please? Because I don't have a full hand. Same thing when you're picking a 7-person subcommittee. If I would have just picked the 3 girls, I would have been like, okay, well, can you give me 4 more people? Because I need 7 people before we can start this meeting. Okay. Here I have 4 aces. That's lovely, but I'm going to sit here and be like, come on, 1 more card. Give me another card, right? So 4 aces and 1 not ace. So how many aces are there? 4, and I choose 4. And aces, or not aces, sorry. It's my short form for sorry. That's not really, I don't know what it is. 48, choose 1. And then this is the tricky one. I've never seen it come up, but most people get it wrong, and then you'll do the homework, and you'll be like, I don't know why this is, because you get it wrong. 5 cards of the same suit. So I can do 13C5 and I have diamonds. But what's my problem?
You have four different suits.
You have 4 different suits. So how many cases am I going to have?
4.
4 cases. Agreed. So we could do 4 diamonds and, my marker's off, 4 clubs and 4 spades. Not and. Come on, Lepp. That's 8 cards now. I can't. And why 4? Come on, Crystal. 5 clubs. Or I could have 5 diamonds. Or I could have 5 hearts. Or I could have 5 spades. And it's or because if I do and, I'm now sitting here holding 20 cards and someone's like, what are you doing? You need 5, you idiot. That's what they're saying. And I'm like, I don't know. That's what I have. So it has to be or, because I could have 5 diamonds here, or throw them down 5 hearts, or throw them down 5 clubs, or throw them down 5 spades, right? That's why the or. And or means I what? Add. Or and add go together, and add do not, even though they sound alike, they're too similar. So 5 clubs is what I need to choose from how many clubs? 13, and then I can go 13 diamonds, choose 5. 13 hearts, choose 5. 13 spades, choose 5. So instead of going 13C5 plus 13C5 plus 13C5 plus 13C5, what could I have done?
13C5 has 4.
Yes. Now on a test, please figure these out and give me actual answers, but I'm saving time. We'll do one of these. We'll do number 2 just for now. NC2 equals 6. NC2 equals 6. If I say algebraically, that doesn't mean go 2C2, 3C2, 4C2, 5C2 till I get 6. That's not algebraically. That's called guess and check. You're like, but I used algebra. No, you didn't. You used buttons on your calculator. So I do know that n has to be what, R? What does n have to be to R? It has to be greater than or equal to. Because I can't like have 1 and choose 2 things. That doesn't make any sense. I can have 2, choose 2. I can have 3, choose 2. But if I say algebraically and you start punching in your calculator, you are not doing algebraically. Algebraically means go to my what? Rhymes with formula sheet. Formula sheet. Good job. Also big brain. So I'm going to go to my formula sheet. It's right here. See, NCR. Look at that. Because it says algebra. I'm going to put it into that. Right there. See that? It's really tiny. You have one in your own binder. You can go find it. That's right there. This is binomial. This is permutation right here. This is where you're going to sit. Exist. Right there. Pretty. Okay. So we are going to go in for n, we're going to put n. In for r, we're going to put r. It's crazy. In for r, we're not going to put r. That's a lie. In for r, we're going to put what? 2. Thank you. So we're going to go n factorial over n minus r, but instead of r, I'm going to go n minus 2 factorial, and then r factorial, which is? So this is that extra thing that I get when it's a c, right? Because it's dividing out all the things that are the same, right? Because we're trying to get rid of all the arrangements, and that's what this does.
Isn't 2 factorial just 2?
It is just 2. So what I'm going to do is I'm going to always multiply this r up right away. And if I multiply that r up right away, I actually just have a permutation formula like I did before. Nothing crazy. So I'm going to multiply the 2 up. And I'm going to get n factorial over n minus 2 equals 10 factorial equals 12. Because 2 factorial is just 2. People are like, why don't I have to factorial? Because 2 factorial is 2 times 1, which is just 2. Okay? And now I just have the same thing as the permutation formula, don't I? What do I do when I have this? You expand the top in this case because it's the bigger one. And the bigger one can become the smaller one. So we're going to expand whichever is the bigger one. The bigger one is n. So n, and then next to it is 1 less than it is, n minus 1, then 1 less than it is. And now I match, so I'm just going to put the factorial over n minus 2 factorial. And then these babies match. Then I get n squared minus n minus 12 equals 0. And I go, what multiplies me negative 12 and adds to give me negative 1?
Negative 4, 3.
Yep. N minus 4, n plus 3. N equals 4. n equals -3. 4 works, because I can go 4C2, correct? Can I go -3C2? Can I have less items than 0 and then choose 2 of them? It makes no sense, so I circle it, put a line through it, and I say extreme. Make sense? Do you remember that one from before? It's literally just one factorial symbol on the bottom, bring it up, and then you're doing exactly what you did in the last thing. Okay, then we're going to flip over. Okay, these are the weird ones they can ask you. These are extensions. In a meeting, everyone shakes hands with everyone else. Does the order in which hands come together make a different handshake? You can make a creepy handshake. Some people shake my hand like this at parent-teacher interviews, which I appreciate not having anymore. But that's just weird. Like, you just kind of like, I actually feel like they're playing with me. Like, are they waiting to see if I'm going to still be kind, or if I'm going to think they're, like, someone's just like, yeah, but I'm like, trying not to laugh, pleased to meet you. Yeah. And they're just doing this. And then some do this, like, take, and I'm like, okay. I'm just like, all right. Good to meet you too. That's the only thing I really miss from parent-teacher interviews is the random, like, weird handshaking things that go on. Sometimes totally miss. Weird. Anyways, order doesn't matter. It does make a creepy handshake, but still weird. When you go to shake someone's hand, next time shake their wrist or their finger and see what they do. It is super awesome. Like, just go and then, like, just, or like go and grab their one finger and just then watch. We don't get the opportunity to shake hands anymore, but if we get that back.
Next time when I go to an interview, I'll make sure.
Oh no. That is not the time. Okay. So order doesn't matter when it's a handshake, right? So we know it's a C at the very least. Do we agree? And how many hands do we shake at a time? Not weirdly. How many hands shake at a time? 2. Not 1, that's even weirder. Just, hello. I'm not talking to anyone, just myself. That's waving in a really weird way. Just, yeah. You gotta turn to the side if you do that. Okay, does that make sense? We're choosing 2 people. It's the same thing as when we do soccer or hockey. You still choose 2 teams to play each other at once, right? Handshakes, 2 people. Soccer, hockey, 2 people, or 2 teams. Okay, in a meeting, everyone shakes hands with everyone else. Still only 2 hands shaking, okay? There are 66 handshakes in total, so what did they give me? Total. We taught this in grade 4 because I know my daughter came home with like a little sheet that gave hints. Total. Equals. So it equals what? Yes, totally. Now they want to know how many people are in the meeting. What are they asking me to find? N. And how do we do this? We don't go 2C2, 3C2, 4C2, 5C2. No. It's going to be on a written response, son. That ain't going to work. So what are we going to have to use? The formula sheet that I was lovingly touching before. Okay? So go. Solve it up. So we get n factorial over n minus 2 factorial. 2 factorial. This part of my board's really wonky. Gets me 132 times 2. So I get n minus 1, n minus 2 factorial, n minus 2 factorial equals 264.
Didn't you?
Oh, I already multiplied by 2. I'm a rebel without a cause. I'm doing a multiplication before I should be. Good job, Lepp. Okay. Now I can't remember ahead. 132. It's going to be a rough go. I'm glad it's Christmas holidays soon. N squared minus n minus 132 equals 0. And what do I get? N minus an n plus. And then I get n equals 12 and n equals negative 11, which makes absolutely no sense. I can't have negative 11 things and choose 2. And then 12, I can check it. I can go 12C2 and I should get 66. If I don't, I'm wrong, because that's what it is. Extension 2. There exists a circle with 6 closed dots on the circumference. 1, 2, 3, 4, 5, 6. Doesn't say where they are. There's just 6 closed dots. How many triangles can be formed using these 6 dots? That's not at all what this is. It's a circle with dots. Nothing. It's better that way. All right. Sometimes.
Yeah.
Okay. So, see, he took it over the line, and then you just catapulted. All right. So, how many of those dots do we need to make a triangle?
3.
We need 3 dots, correct? Now I have to decide with those 3. Does the order matter in which I pick those 3 dots? Does the triangle change?
It's still a triangle. It does change.
Does the order in which I pick them change the triangle? No, because if I go like this, or go like this, or go like this, because I'm a rebel without a cause, I still have the same triangle. We agree? Like if I go like this, or go like this, or go like this, still the same triangle. So does the order in which I pick those 3 dots matter?
Those lines are a little off.
I have marked your test. I have seen your handwriting. Don't comment about my dots.
That's fair.
Right? Yeah.
Yeah, you guys sweet up.
Yeah. It's kind of hard sometimes. I struggle. The struggle's real. But yes, my lines are not perfect. Oh my gosh. There's the big circle that they're connected to. Okay. So what do? We do C. This is true. What do we do? 6.
Yeah, 6 C.
C3. Yes. What do we get?
5. 20. But
Now, could they have given me the total number of triangles and asked for the number of dots? Yeah, and then I would go NC3 equals whatever the total they gave me, right? So when they give me total, I have to set it equal to it. If they give me total, they're literally asking me to use the formula, right? Neatly use the formula. Just kidding. Sort of. Okay, extension 3 says every team in a league plays every other team 3 times. Now they're going to have to, if it's a question like this, they'll have to tell you how many teams play at once. So like, they'll say soccer, and 2, then you'll know soccer or hockey or baseball. How many teams play each other at once? 2. That's it. They'll pick a sport that you know, or they'll say 2 teams play at once. So, does the order in which I pick them matter? No. And I'm always going to make them not matter. I'm just going to tell you that right now. When I do teams, I always just pick 2 at once and I make it a C. And the moment I make it a C, that means they're playing each other once. I'm making home and away not matter. If I put a C, the 2 team orders don't matter. So I'm forcing it to be a not matter. Okay? Now here it says every team in a league plays each other 3 times. So if I go NC2, that's them playing each other once. If you do NP2, just so you know, that's them playing each other twice, which is actually harder to do. It isn't if it's like twice, because twice means home and away, right? Twice means each team is a home and away. So I don't ever go that route because they said 3 times. So now I would have to do NP2 and then times with like a half. Like, what am I going to do? So instead of doing this, I always go NC2, and this represents them playing once. And then if I just need them to play 3 times, what do I just do to that? Times by 3. If I need them to play 5 times, times by 5. If I need them to play 2, I'll just times it by 2 instead of doing NP2. But if it was twice, I could use NP2 and then times it by nothing. So they play each other 3 times. So I'm going to go 3 times NC2. How many teams are in the league if they play a total of 198 games? What's total mean? Equals. How can I solve this?
Using algebra.
Yes, this is true. Wow. What would I do first?
Divide by 3.
Divide by 3, and then find the formula. Yes. What's 198 divided by 3? 60.
66.
Wasn't that 66 up there?
Yep.
Look at me.
I haven't gained any trust.
No, my brain just remembered the 66 in my head. And I was like, didn't we just do that? We did do it right here. It's the exact, it's gonna be 12. If this is this. NC 266 is 12. That's why my brain was like, we just did it. Even though these are my notes, I don't know how I just connected that now, but pray for me, it's fine. N factorial, I'll prove it anyways. N minus 2 factorial, N factorial over N minus 2 factorial equals 132. It's the exact same work as above. You could say C extension 1 if there's more. Oops. Oh. Now, if this was a diploma question or a test question, it's a word problem, correct? It's going to need a sentence. So you would say there are 12 teams in the league. Now, please, some of you guys weren't doing this. If you get an answer, you need to box the answer that's correct. Yes? You also need to box or circle and put a line through and say extraneous, the ones that are not good. So what I've seen people doing is they're putting a circle and they're boxing and they're saying extraneous. Everyone's doing really good there, and then just leaving everything else just sit. You have to box your answer, because that's how the person who's marking it knows you know that the answer is 12. Okay? If you don't box the answer but you write a sentence, that would work too, because then you're saying what the answer is. If you write a sentence that says there are 12 teams in the league, you literally just told that was what the answer is. But if you don't box n equals 12 and you don't give a sentence, it's just you just have work sitting on your page. But we know that this one doesn't work. That's all I know. Okay? All right. We're going to move. I'll come back to this for anyone who's copying down. But we're going to move ahead to here. Move ahead to here. This is going to be tomorrow. See, at least in at most cases. This is going to be your homework that is going to be due once we learn the at most and at least part of it. And then when we come back, we have binomial theorem, 2 radical lessons, 2 rational lessons. So the first week is lessons. I'm going to try and slam them into 4. And then you have a unit test, cumulative, midterm. That is not true. Unit test, cumulative, mock, and a final on the 20th. So remember, when you come back, it's 17 days till your diploma. 17.
So what you're saying is you have 17 days to get my...
To 20.
Why didn't I think of